The world of technology is no stranger to disruption. From the first computers to the internet, innovation has constantly reshaped our lives. Today we stand at the cusp of another technological leap, the age of artificial intelligence. Specifically, generative AI is making waves in various fields, including the seemingly exclusive domain of computer programming. This new breed of AI can write its own code, prompting a significant question. Can AI replace human programmers altogether? The prospect of machines writing complex software seems like something out of science fiction. Yet AI-powered tools are already automating tasks that were once the sole domain of human programmers. From generating simple lines of code to debugging complex programs, AI is rapidly changing the face of software development. This rapid advancement has sparked both excitement and apprehension. While some see AI as a powerful tool to enhance productivity and creativity, others fear it could render human programmers obsolete. This essay delves into the capabilities and limitations of generative AI in programming, exploring its potential impact on the software engineering profession. We will examine how AI is poised to augment, rather than replace, human programmers, leading to a future where both collaborate to build the software that powers our world. Before we delve into the implications of AI in programming, it's crucial to understand what generative AI is and how it differs from traditional software. At its core, generative AI is a type of artificial intelligence that focuses on creating new content, whether it's text, images, music, or in this case, code. Unlike traditional software that follows pre-programmed instructions, generative AI learns from vast datasets and uses this knowledge to generate novel outputs. Imagine feeding a generative AI model millions of lines of code. The AI analyzes these examples, identifies patterns, and learns the underlying rules of programming. This process allows the AI to write its own code, often in response to specific prompts or instructions. For instance, a programmer could ask the AI to create a function that sorts a list of numbers in ascending order, and the AI would generate the corresponding code. This ability to generate code has significant implications for software development. It can automate repetitive tasks, such as writing boilerplate code or generating documentation, freeing up human programmers to focus on more complex and creative aspects of software design. Moreover, generative AI can assist programmers in learning new programming languages and frameworks by providing code examples and explanations. However, it's important to remember that generative AI is still in its early stages of development. While it excels at specific tasks, it lacks the broader understanding, critical thinking, and problem-solving skills that characterize human programmers. Generative AI is rapidly becoming an indispensable tool in the programmer's arsenal, offering a range of benefits that significantly enhance efficiency and productivity. One of the most notable strengths of AI in programming lies in its ability to automate repetitive and time-consuming tasks. Writing boilerplate code, a necessary but often tedious aspect of programming, can now be delegated to AI, freeing up developers to tackle more intellectually stimulating challenges. Moreover, AI excels at generating documentation, a crucial yet often overlooked aspect of software development. By analyzing code and understanding its functionality, AI can automatically generate comprehensive documentation, saving developers countless hours of manual effort. This not only accelerates the development process but also ensures that documentation remains up to date and accurate. Beyond automation, AI brings a new level of intelligence to code completion, providing developers with contextually relevant suggestions and snippets as they type. This intelligent code completion goes beyond simple syntax suggestions, offering more sophisticated recommendations that take into account the overall structure and logic of the code. This significantly speeds up the coding process and reduces the likelihood of errors. Furthermore, AI can assist with debugging, a task that often consumes a significant portion of a developer's time. By analyzing code and identifying potential issues, AI can help developers pinpoint and resolve bugs more efficiently. This not only saves time, but also improves the overall quality and reliability of the software. While the advancements in AI-powered programming tools are undeniable, it's important to recognize the limitations of this technology. Generative AI, while impressive in its ability to learn patterns and generate code, still falls short in areas that require human ingenuity, creativity, and a deep understanding of context. One of the key limitations of AI is its reliance on existing data. AI models learn from the data they are trained on, and their outputs are only as good as the data they have been exposed to. This means that AI can struggle to generate truly novel solutions or handle scenarios that deviate significantly from the patterns present in their training data. Human programmers, on the other hand, possess the ability to think abstractly, draw from diverse experiences, and come up with innovative solutions that go beyond existing paradigms. Furthermore, AI often lacks the nuanced understanding of human intent and context that is crucial in software development. Software is rarely created in a vacuum. It exists to solve real-world problems for real users. Human programmers excel at understanding the needs of users, interpreting ambiguous requirements, and translating them into functional and user-friendly software. AI, at least in its current state, struggles to replicate this deep understanding of human needs and desires. Moreover, AI lacks the ability to effectively collaborate and communicate with humans in the nuanced ways often required in software development. Building complex software systems involves constant communication, negotiation, and compromise among teams of developers, designers, and stakeholders. Section 5. Augmentation, not replacement, the future of software engineering. The question of whether AI will replace human programmers has been a topic of much debate. While AI's rapid progress in code generation and automation is undeniable, it's crucial to recognize that AI is more likely to augment rather than replace human programmers in the foreseeable future. The relationship between AI and programmers is better understood as a collaboration, where each leverages their respective strengths to achieve superior outcomes. AI can handle repetitive tasks, provide intelligent suggestions, and assist with debugging, freeing up human programmers to focus on higher-level aspects of software development. This includes tasks that require creativity, critical thinking, problem-solving skills, and a deep understanding of human needs and context. The future of software engineering lies in embracing this collaborative dynamic. Programmers who adapt to this changing landscape and learn to effectively leverage AI tools will be best positioned to thrive in this evolving industry. This requires a shift in mindset from seeing AI as a threat to recognizing it as a powerful ally that can enhance their capabilities and productivity. The role of a programmer will likely evolve, with a greater emphasis on tasks such as defining high-level system architecture, designing user experiences, ensuring code quality and security, and collaborating with both human and AI team members. Section 6. Riding the Wave. Adapting to an AI-driven industry. The rapid advancement and adoption of AI in programming necessitate a fundamental shift in the software engineering industry. To remain competitive, businesses and individuals alike must embrace this transformation and adapt to the new realities of an AI-driven landscape. For businesses, this means investing in AI-powered tools and infrastructure that can streamline development processes and enhance productivity. It also requires fostering a culture of continuous learning and upskilling, encouraging employees to embrace AI as a collaborative partner. Companies that successfully integrate AI into their workflows and empower their employees to leverage these technologies will be better positioned to innovate and stay ahead of the curve. For individual programmers, adapting to an AI-driven industry requires a willingness to embrace lifelong learning and continuously update their skills. This includes not only mastering new programming languages and frameworks, but also developing a deep understanding of AI concepts and how to effectively utilize AI-powered tools. Furthermore, programmers need to develop the ability to work alongside AI, understanding its strengths and limitations. This requires a shift in mindset from seeing AI as a competitor to recognizing it as a powerful ally that can enhance their capabilities. The ability to effectively collaborate with AI, interpret its outputs, and ensure the quality and ethical implications of AI-generated code will be crucial skills for programmers in the future. Section 7. The Skills Imperative Education and Reskilling for the Future. As AI continues to reshape the programming landscape, the demand for professionals with the right skills will continue to grow. Traditional computer science education will need to adapt to equip aspiring programmers with the knowledge and skills required to thrive in an AI-driven world. This includes incorporating AI concepts, machine learning principles, and data science techniques into the curriculum. Furthermore, educational institutions should provide hands-on experience with AI-powered programming tools, enabling students to develop practical skills in using these technologies effectively. Beyond formal education, reskilling and upskilling initiatives will play a crucial role in preparing the existing workforce for the challenges and opportunities of AI-driven programming. Online courses, workshops, and boot camps can provide professionals with the necessary knowledge and skills to stay relevant in this rapidly evolving field. Governments and industry leaders should collaborate to create accessible and affordable reskilling programs, ensuring that no one is left behind in the transition to an AI-powered workforce. The skills required for programmers in an AI-driven world extend beyond technical proficiency. As AI takes over more routine tasks, human skills such as creativity, critical thinking, problem-solving, communication, and collaboration will become even more valuable. Programmers who can effectively communicate complex technical concepts to both technical and non-technical audiences, work collaboratively in diverse teams, and approach problems from multiple perspectives will be highly sought after in the future job market. Section 8. Ethical Considerations. Navigating the societal impact of AI in programming. The increasing use of AI in programming raises a number of ethical considerations that must be carefully addressed. One of the primary concerns is the potential for bias in AI-generated code. AI models are trained on vast datasets, and if these datasets reflect existing biases in society, the resulting AI systems may perpetuate or even amplify these biases. This could lead to the development of software that discriminates against certain groups of people or reinforces existing inequalities. It is crucial to ensure that AI systems used in programming are trained on diverse and representative datasets, and that mechanisms are in place to detect and mitigate bias in AI-generated code. Another ethical consideration is the impact of AI on the job market. While some argue that AI will create new job opportunities, others fear that it will lead to widespread job displacement, particularly for entry-level programming roles. It is essential for policymakers, industry leaders, and educators to work together to address these concerns by investing in education and training programs that prepare workers for the jobs of the future, and by creating social safety nets for those who may be displaced by automation. Furthermore, the use of AI in programming raises questions about accountability and transparency. When AI systems generate code, it can be challenging to determine who is responsible for errors or unintended consequences. It is important to establish clear lines of responsibility and to develop mechanisms for auditing and explaining AI-generated code to ensure that these systems are used responsibly and ethically. Section 9. Conclusion. A symbiotic future. The rise of generative AI in programming is undeniably transforming the software engineering landscape. While AI excels at automating tasks, generating code, and enhancing efficiency, it's essential to recognize that human ingenuity, creativity, and problem-solving skills remain irreplaceable. The future of programming lies not in a battle between humans and machines, but in a symbiotic relationship where each leverages its strengths to achieve superior outcomes. As AI continues to evolve, programmers who embrace lifelong learning, adapt to new tools, and focus on developing uniquely human skills will thrive in this dynamic field. The key lies in viewing AI not as a threat, but as a powerful ally, a collaborative partner that can augment our abilities and push the boundaries of what's possible in the world of software development. By embracing this collaborative spirit and navigating the ethical considerations thoughtfully, we can harness the full potential of AI to create a future where technology empowers and enhances human capabilities, leading to a more innovative and inclusive digital world.